Morning students, welcome to the Science 1 class. Students, in the previous video, we learnt about how to calculate the mass of a single atom. Today, we are going to learn another important and interesting topic called relative atomic mass, simply called RAM. What is meant by relative? The relative means comparing with other elements. So we are going to see the relative atomic mass comparing with other elements. How can you find the mass of 1 kg vegetables? Well, you put 1 kilogram stone in one side of the balance and vegetable in other side of the balance. When both sides are balanced, we say that the mass of vegetables is equal to 1 kilogram. Now, listen carefully. The mass vegetable is relative because it is compared to 1 kilogram stone. Secondly, 1 kilogram stone is a standard unit which is used to measure the mass of different things. Let's once again we remember that the mass of vegetable is relative and the 1 kilogram stone is standard unit. Now we will measure the mass of an atom of particular element just like a fruit seller measure the weight of the fruits while selling it in the market. You have to implement here. So what scientists have done, they have taken a similar vessel so the volume is constant. So they fill different elements in this oxygen. Second one, hydrogen, nitrogen, chlorine. They weighed it the masses nearly the mass of oxygen is 32, hydrogen 2, nitrogen 28 and chlorine is 71. Further, they divided by common number. So they have got the final number 16 for oxygen, hydrogen 1, nitrogen 14 and chlorine 35.5. We release for hydrogen. So they take as a standard. It's not just arbitrary value, just comparison they have taken 1. What is the oxygen value? They got 16. So can I say like this oxygen atom is 16 times heavier than hydrogen, right? As I said, so oxygen atoms are 16 times heavier than hydrogen. So, relative atomic mass of oxygen is 16 in hydrogen scale. Similarly, come to nitrogen. In this method, we have got the value 14. So, the nitrogen is 14 times heavier than hydrogen. Similarly, chlorine, this is 35.5 times heavier than hydrogen, right? This is called relative atomic mass. So we are comparing. We will take one atom is a standard. The another atom will compare. The mass of other atom will be comparing with this atom so that mass can be calculated. I hope you understand this. So I am going to see some standard. The scientists have used various standards depending upon the time. Now the first standard was hydrogen. The reason is it is a very lightest element, and what are the drawbacks after existence of isotope of hydrogen? So the atomic mass of hydrogen is not exactly equal to 1. So the mass is somewhere near to 1.008. So nowadays they didn't used as a standard. Now come to the next standard, oxygen. The reason is it's react with most of the elements, that's why they have chosen oxygen as a standard. But later they come across the problem again. The existence of oxygen, there are three isotopes, and the atomic mass is not exactly to be 16. So far, these drawbacks they withdraw the oxygen. Now, come to the third standard. Nowadays, we follow this carbon 12 isotopes. We are not saying oxygen. We are particularly specific about isotope carbon 12. Isotope carbon has three isotopes, C12, C13 and C14. We are not talking about C13 and C14 isotopes. We are talking about C12 isotope because in the nucleus it has 6 protons and 6 neutrons. So the mass number will be 12 exactly. That's the first reason we have selected for this. Next, the existence of carbon 12 isotope is nearly 99%. Yes, the other two isotopes are available only in the living things like plants and animals. You might come across the carbon 14 is a radioactive isotope. So largely this I can say almost 100% this carbon 12 isotope is exist in the atmosphere. So if you take this as a standard, the calculation will be easier and tidy. That's the reason they have chosen this is as a standard. Now let us go to the next one. How do we calculate relative atomic mass? We know very well that atoms are amazingly small. So the mass is definitely very small. So if you weigh the atoms in the electronic balance, you will get very silly answer. There is no such a electronic balance to measure such a small mass. So, the mass of an element is compared with the mass of atoms of carbon 12 isotope. That's why I said earlier compare it is. So they compare with one element, they will find out mass of the other, right? What they have done, the carbon 12 atom, they have divided into 12 equal parts. Why? And explain this why. We say 1 by 12th of mass of one carbon 12. Why do we divide a carbon atom into 12? So that one part we consider as a 1 AMU. Because in the carbon scale, which is the least value, that's what we have to identify. Let's compare this. An atom of magnesium 12, magnesium 24 weighs twice as we compare to carbon 12. Yes, you are right. Look at the carbon mass, isotope 12. The magnesium mass is 24. Definitely, if you multiply by 2, you will get 24. So, that's why we say an atom of magnesium weighs twice as we compare to 12. Look at the hydrogen atom. An atom of hydrogen is 1H1. Weighs only 1 by 12th of that carbon 12, right? The mass when you compare it is 1 by 12 of mass. So what is the basic unit here? 1 by 12 of mass of carbon 12 is a mass of hydrogen. That's what the basic unit we say. So we say 1 by 12 mass of carbon 12 atom. Because in the carbon scale, the least atom has the mass of 1 by 12 mass of carbon 12. Let us go to the next example, lithium. lithium 3 7. 7 is the mass of lithium as far as the scale carbon 12. So what we have understood, very simple one, atom of lithium is 7 times heavier than 1 by 12 mass of carbon 12 isotope, right? Let us go to the next example. Let's take the case of sodium. So the mass number is 23 on the carbon scale. So it is simple idea. Here 23 times the sodium is heavier than 1 by 12th of mass of one carbon 12 atom. Right? Let's go to some more informations. What is meant by RAM? It otherwise called standard atomic weight. It denoted by AR. Now what is this? It is a ratio. We are comparing with the carbon 12, 1 by 12th of mass of one carbon 12 isotope. This otherwise called one atomic unit. The formula for relative atomic mass, AR is equal to average mass of the isotopes of the element divided by 1 by 12th of the mass of one carbon 12 atom. Thank you.